To a user reading an article, loading text on a screen feels entirely effortless. But beneath the surface, calculating exactly where each word belongs is actually one of the most computationally demanding tasks a browser performs. Every time a browser uses standard methods to measure a paragraph, it triggers a layout reflow. The engine has to recalculate the geometries of the entire page layout, burning through valuable processing cycles. Developers have built clever tools on the CPU side to handle this. Libraries like Pretext bypass the browser's document object model entirely, using pure JavaScript arithmetic to measure text near instantly. These tools solve the layout calculation. They figure out the exact width of every line and place the invisible bounding boxes exactly where the words need to go. But knowing where a letter goes is only half the battle. The physical act of taking that invisible box and drawing a readable character onto the pixels of your screen remains a deeply fragile process. Traditional text rendering relies on texture maps, pre-rendered pictures of letters cached in graphics memory. Because they are fixed images, they break down when scaled up massively or viewed at oblique angles, forcing the square pixels to stretch and blur. The hardware struggles to guess what the edges should look like. The result is a mess of dropped pixels, jagged stair-step edges, and flickering sparkles along the boundaries. To fix this, developers needed to abandon cached images entirely. They had to take the mathematical ground truth of a font, the geometric curves themselves, and map them directly to the graphics hardware. Static, rasterized pictures simply cannot survive the dynamic scaling and rotational demands of modern interfaces. For text to remain perfectly crisp under any condition, it has to become pure geometry. This requires leaving the 2D web layout behind and entering the hyperfast parallel processing environment of the GPU. In 2016, Eric Lengyel developed what is now known as the Slug algorithm. It completely replaces pictures of letters with the raw mathematical Bezier curves that make up the font. Slug organizes those curves by systematically slicing the glyph's outline into intersecting vertical and horizontal bands. The GPU evaluates these intersections in real time, calculating a winding number to definitively decide which pixels fall inside the letter and which remain outside. But there was a mathematical vulnerability. At the extreme microscopic edges, floating point round-off errors occur. When a pixel is only partially covered by the curve's boundary, the rasterizer can occasionally drop it, creating visible artifacts. A mathematically perfect curve fails if the hardware fails to draw the right pixel. The geometry required an actively adaptive boundary to survive the final render. In 2019, Lengyel introduced dynamic dilation to automatically expand the bounding polygon around every single letter. By expanding outward to this exact distance d, the system guarantees the rasterizer catches every partially covered pixel, expanding by exactly half a pixel in viewport space. The algorithm passes the vertex through the MVP matrix, calculating exact spatial distortion by solving this quadratic equation. U squared plus V squared minus S squared times T squared times D squared minus 2S cubed TD minus S to the fourth equals 0. This calculation executes instantaneously inside the vertex shader for every single glyph. It dynamically produces the optimal padding, ensuring no GPU resources are wasted on empty space. Dynamic dilation bridges abstract geometry and visual reality. It renders text flawlessly without requiring a developer to manually tweak the padding values. This system for resolution-independent rendering was adopted by the largest studios in the industry, including Blizzard, Ubisoft, and id Software. They used it to render massive, crystal-clear text inside complex 3D environments. But for an entire decade, this perfect text rendering was locked behind expensive enterprise licenses and a strict utility patent. That changed in March 2026. Believing the patent had already served its purpose, Lengyel permanently and irrevocably dedicated the Slug algorithm to the public domain. The fallout was immediate. With the intellectual property restrictions gone, developers rushed to integrate the algorithm into the modern web ecosystem. This flowchart illustrates the new open-source pipeline. Projects like Slug Web GPU fully port the algorithm to the browser, running text shaping on the CPU with TypeScript and pushing the resulting curves directly into a highly optimized web GPU pipeline. Flawlessly sharp, Infinite scaling vector text is no longer a walled garden reserved for massive game studios. The math is free, giving every developer the power to build perfect interfaces across the open web.